discussed about binomial distribution, where we have two types of problems. A direct one asking fit a binomial distribution and other case. Set you the second distribution to be discussed is Poisson. That also you'll have two cases like the previously discussed problem where an indirect one will be given, and the second case here is nothing but a direct question like fitting of Poisson distribution. Means from binomial and Poisson you'll get one numerical problem where he may ask a direct question like fit a binomial or fit a Poisson distribution. Other one is nothing but like indirect question which we have discussed. Now I am discussing fitting of Poisson distribution. We know that we write whenever x is x, we call this as follows. We say that if x is a Poisson variate, we write x follows Poisson distribution, which is nothing but xpm. And whenever it follows a distribution, you will have a respect to PMF. The PMF of Poisson distribution is e power minus m power lambda power m by x factorial. Now, as m is the parameter here, you should calculate m to fit the particular distribution. These are called the parameters. Similar while doing for binomial distribution, as n comma p are the parameters of binomial distribution, we have calculated p there. Similarly, as m is the parameter in Poisson distribution, you should calculate m. Now, as we have discussed earlier, fitting of any distribution involves three steps. Like the first column always given is treated as x. Second one is called f. You need to find out probabilities, and then expected frequencies. The formula for expected frequencies is n into p of x. So, I think if you have understood the binomial distribution, the major steps in fitting is same, where the first two columns are considered as x comma f. You need to calculate the third column called p of x using the corresponding PMF. Then you should calculate expected frequencies by using the formula n into p of x. So the condition here is nothing but the total of these frequencies should be equal to the total of the calculated expected frequencies. So let us go to the problems. The given first column is nothing but 0, 1, 2, 3, 4, 500. What I said, to calculate this p of x, you should calculate this is m power x, e power minus m lambda power m by m factorial. E power minus m, m power x by x factorial. So this is the formula for Poisson distribution. So you should calculate m first. M is nothing but mean of Poisson distribution. So this m can be obtained by, we know that the formula for mean is sigma fi xi by sigma fi. So to calculate p of x, you should know m. M is nothing but mean of Poisson distribution. So to calculate m, we should calculate mean for the given distribution. So this is x, f, fx. You know how to calculate mean, the regular calculation. So to calculate m, I have formulated this table as m is equal to sigma fi by xi. So the total of this is nothing but 710. So m will be 710 by sigma f is nothing but 1000. So I got this as 0.71. So I have obtained the value of m. Now I should go for fitting, where you should calculate p of x column first. What is this p of x here? You need to calculate p of 0, p of 1, p of 2, p of 3, P of 4. Let us calculate all those separately and then substitute here. Then you multiply with n to get this column. So let us calculate P of 0, P of 1 and all. So what is P of x? P of x is e power minus m power x by x factorial. So P of 0 means e power minus 0.71 whole power 0 by 0 factorial. So which is nothing but e power minus 0.71 means you can sometimes you will be allowed with the calculator, or this value will be given to you in the brackets in the question itself. E power minus 0.71 value will be given to you. Otherwise you will be sometimes calculators will be allowed. So e power minus 7 value is nothing but 0.472. So e power minus 0.71 value is obtained from calculator, or in the question itself the value will be directly given to you. Now let us calculate P of 1. E power minus 0.1, 0.71 whole power 1 by 1 factorial, which is nothing but 0.492 into 0.71. Okay, so which is nothing but 0.349. Similarly, P of 2 is nothing but e power minus 0.71 into 0.71 whole square by 2 factorial. So 0.492 into 0.71 square by 2 factorial, which is nothing but 0.124. P of 3 is nothing but e power minus 0.73, 0.71 whole power cube by 3 factorial. Similarly, by simplifying this, you will get 0.293. P of 4 you need to calculate last one. E power 0.71, 0.71 whole power 4 by 4 factorial, which is nothing but 0.0052. So we have calculated for fitting. I said you need these values. We have calculated those, and we go. Please fill this column. After calculating this, to calculate expected frequencies, the formula is n into P of x. The total of this is always frequencies is indicated with capital N. So this is nothing but 1000 into 0.492 into 1000, which is nothing but 492. Next one is 0.49 into 1000, which is nothing but 349. So I got these as the expected frequencies. I said you fitting of either Poisson or binomial distribution is verified by checking that the total of these values should be approximately equal to these values. So if you add these values, I think you will get a value which is nearly equal to 500. So we can observe here 500 is divided by 8 here. 340 is approximately equal to 349. Here we have 9 more and we have 8 less, means these two are balanced. And here also we observe that there is a slight difference. So by adding all these values, you will get a value which is nearer to 500. So whatever we have done, that is fitting of Poisson distribution is correct. Okay, thank you.